Assalamualaikum. Okay, this video is about RLC resonant circuit analysis using MATLAB. Figure 1 show a RLC series circuit in S domain. Firstly, we need to find IS in S domain. They have provided us the resistor equal to R, inductor equal to J omega L, and capacitor equal to 1 over J omega C. To find IS, we have to find the impedance Z equal to R plus L plus C. Insert the value of R, L and C, so it will become Z equal to R plus J omega L plus 1 over J omega C. Simplify the equation so the impedance Z equal to R plus J bracket omega L minus 1 over omega C. Substitute the delta Z into IS equal to V over Z. Then IS equal to 1 over R plus J bracket omega L minus 1 over omega C. Then we need to calculate the resonant frequency. There is omega naught. We use the capacitor equal to 2 microfarad and impedance L equal to 1 millihenry. The formula from resonant frequency is omega naught equal to 1 over square root LC. Unit is rad per second. Insert the value of C and L into the formula and we can get our omega naught equal to 22.361 kilo rad per second. Now, we have to find the first initial quality Q1 and its bandwidth B1. We use the R equal to 15 ohm, the C same as before, and the inductance also the same as before. There is C equal to 2 microfarad and L equal to 1 millihenry. The quality factor Q equal to 1 over omega naught C times R. Insert the value and we can get Q1 equal to 0.4472. And for the bandwidth, the formula is B1 equal to omega naught over Q1. Then we can get B1 equal to 50 kilohertz. Next, we need to change the parameter to increase the value of initial quantity factor Q1. We reduce the value of R equal to 25 ohm and the value of C and L remain the same as before. We get Q2 equal to 0.8944 and B2 equal to 25 kilohertz. Then we need to change the parameter to decrease the value of initial quantity factor Q1. This is the third quantity factor Q3. We increase the value of R from 50 ohms to 100 ohm and the value of the C and L remain the same. Will we get Q3 equal to 0.2236 and B3 equal to 100 kilohertz.
Okay, next we will show you the Q1, Q2 and Q3 in MATLAB software. Okay, Q1, as we can see, we use capacitor 2 microfarad, R equal to 50 ohm and L equal to 1 millihenry. Then we simulate, we will get this graph for Q1. For Q2, we change the value of R to 25 ohm. We decrease the R to make the quality factor increase. So we simulate, then we will get this type of graph. Next is Q3. In Q3 we use R equal to 100 ohm, and capacitor and inductor will remain the same. When we simulate, we will get this type of graph on. Okay, next we will compare the value of Q1, Q2 and Q3. We can see here that Q1 is a medium which locate in the middle of the graph. Q2 has the highest value, so it will be on top of the graph, and Q3 value is the lowest, which is the green one. Okay, for the sensitivity, Q3 has the least sensitivity compared to the others. Q1, as in the middles, it will have medium sensitivity, and Q2 has the highest sensitivity for among of those. Application. The selection application of quality initial factor. The selection of AM radio station by radio receiver. The selectivity of the tuning must be high enough to discriminate strongly against station above and below in carrier frequency, but not so high as to discriminate against the sideband created by the imposition of the signal by amplitude modulation. The selectivity of a circuit is dependent upon the amount of resistance R in the circuit. The smaller the resistance, the higher the quality factor for given values of L and C. The parallel resonant circuit is more commonly used in electronic, but the algebra necessary to characterize the resonance is much more involved. For the function of series resonant circuit are used to respond selectively to signal of a given frequency while discriminating against signal of different frequencies. If the response of the circuit is more narrowly peaked around the chosen frequency, we say that the circuit has higher selectivity. A quality factor Q, as described below, is measure of that selectivity, and we speak of a circuit having a high Q if it is more narrowly selective. Thank you.